All right, today we're going on the ultimate journey. And no, I don't mean through space, I mean through time. We are heading way, way into the future to see how our entire universe might actually end. You ready? Let's go. This quote from Helen Keller really sets the stage perfectly. We're about to head into a future of, well, darkness and silence. But that doesn't mean it's not full of its own kind of cosmic wonders. And seeing that far off future, it really helps you appreciate our own little moment in the light, right here, right now. So that's the big one, isn't it? How will the universe meet its end? With a bang, a whimper, fire, ice? The classic questions. And look, while we don't have all the answers, what we do have from science is, well, it's a pretty stunning and honestly a surprisingly detailed picture of what's coming. Okay, so here's how we're going to do this. We're basically hitting a cosmic fast-forward button, traveling exponentially faster through time. First stop, the relatively near future. We're going to see humanity's legacy just fade away, and then stick around for the pretty violent end of our own solar system. And wow, on a cosmic scale, everything we've ever done, it vanishes surprisingly fast. Think about it. The Apollo footprints on the moon, gone in 500,000 years. Our giant stone monuments, dust in 1,000,000. Even Saturn's incredible rings will be gone in just 8 million years. It's a pretty humbling reminder that even our greatest achievements are just temporary. Okay, now we're taking a huge leap forward, about 5 billion years. This is when our sun starts to die. It's running out of fuel, its core collapses, and bam! A furious blast of heat makes its outer layers swell up like a giant balloon. It becomes a red giant. And for Earth, it's bad news. The oceans boil away, the surface gets scorched to a crisp, and then our planet gets swallowed whole. That right there is the end of our world. So with our sun gone, we enter a totally new era for the universe. It's called the Degenerate era. And yeah, it's named that for a reason. All the stars have finally burned out, and the only things left are their corpses, these degenerate remnants. The age of starlight, the universe we know, it's officially over. Yeah, a cosmic boneyard. It sounds dramatic, but it's actually a perfect description. The universe at this point is just a dark, cold graveyard. No new stars are being born. All that's left are these stellar remnants, just slowly cooling in an endless night. It's a universe of ghosts, really. So what about our sun? What's left of it? Well, it's now a white dwarf. And it's not really a star anymore. It's more like a stellar core, super, super dense, about the size of Earth, and it's just glowing faintly from leftover heat. Imagine this. If you were standing where Earth used to be, it would look no brighter than a full moon. And that's it. These things are the only lights left in the entire universe. But wait, because after trillions of years, even that faint glow is gone. The white dwarf cools down completely and becomes a black dwarf, basically a cold, dead piece of a star. And here's a wild thought. This process takes so unbelievably long that scientists are pretty sure that not a single black dwarf exists anywhere in the universe yet. Our universe is still way too young for them. Okay, so the stars are gone, the remnants are fading. It's time for new main characters to take the stage. The universe is now entering the black hole era. These things, these gravitational monsters, they're not just side characters anymore. Oh no, they are the main event, and they're going to run the show for trillions and trillions of years. And don't for a second think this is a quiet, peaceful era. When these massive black holes, which are just wandering through what are basically zombie galaxies, finally find each other, well, the collision is anything but silent. They bang on space-time like mallets on a drum. The energy they unleash is just unbelievable. So what is that energy? It gets released as gravitational waves, and this is so cool. These aren't waves moving through space. They are literally ripples in the very fabric of space-time itself. It's like space is a pond, and something just dropped a huge rock in it. You've got the sound of space itself squeezing and stretching, a ringing that echoes across the universe at the speed of light. But here's the thing. Even black holes don't last forever. The great Stephen Hawking figured this out. He theorized that they slowly evaporate. It's a process called Hawking radiation. Basically, right at the edge of a black hole, pairs of tiny particles pop into existence. Sometimes one gets sucked in, but the other one escapes, and it takes a tiny piece of the black hole's energy with it. It's like a cosmic slow leak. And over an almost infinite amount of time, every single black hole will just evaporate. So what's left after the last black hole is gone? Well, this is it. We're entering the final chapter of the universe. All the matter, all the structure, it's all gone or decayed. The cosmos is staring down its ultimate fate, just becoming a cold, empty, and totally unchanging void.
Now, even before the last black holes disappear, there's another theory about what might be happening. It's called proton decay. The idea is that protons, the fundamental building blocks of atoms, will just fall apart on their own. Now, this is just a theory. It's unproven. But if it's true, it means any matter that managed to survive, like those cold, dead black dwarfs, will just disintegrate. They'll evaporate away into nothing but radiation.
And what's the engine driving all of this? Pushing everything further and further apart? Well, it's something called dark energy. And honestly, this is one of the biggest mysteries in all of science. It's some kind of weird, repulsive force that's just part of empty space. And it's making the universe expand faster and faster all the time. So, what this dark energy does next basically decides everything. It's like we have 3 possible endings. Will gravity somehow win out and pull everything back together in a big crunch? Or will dark energy get even stronger and literally tear atoms apart in a big rip? Or, and this is the one most scientists are betting on, will we just get the big freeze? The universe just keeps expanding forever, getting colder, darker, and emptier until we reach what's called heat death. Okay, wow. After that trip into the absolute abyss, let's pull it back for a second. Let's come back to right now. Because thinking about that long, dark, empty future, it gives you a totally new perspective on the present, doesn't it? It turns out that our time, this amazing age of stars and galaxies and life, it's an unbelievably brief and precious moment. Just how brief are we talking? Well, the time when life like us is even possible, it's a fraction of the universe's total lifespan, so small it's hard to even write down. It's 0 point, and then 83 zeros, and then a 1%. It's a number so small it's practically zero. We live in this tiny, fleeting little haven in time, perfectly nestled between a fiery birth and an icy death. And this is the end of the story. After the very last black hole evaporates in one final flash of light, the universe is just a quiet sea of photons, slowly cooling to absolute zero. And because everything is at the same temperature, nothing can ever change again. Entropy, the arrow of time, it just stops. Time itself loses all meaning. Nothing happens forever. So we come all the way back to that Helen Keller quote from the beginning, but now we get the second half. This whole journey to the end of time, it shows us a future of darkness and silence, but it also shows us just how incredible and profound our own existence is. It teaches us that in this tiny, shining moment that we have, we get the entire cosmos to explore, and for that, we can definitely be content.